Good evening, Ms. Fazlin. My name is Lai Kasim, and in this video, I'd like to present a few questions in topics 5 and also topic 6. So for the topic 5 matrix, the questions number 1D. The questions given 3 linear equation, and the D1 need us to write matrix equation. So in the AX equal to B form, A is the number in front of the unknown, which is called coefficient. So X is the unknown from the linear equation, which is P1, P2, and also P3. And B is 12, 13, and also 17. Next, the questions D Roman 2 need us to get the determinants for the coefficient matrix. So for the determinants A, to calculate the determinants A, the number I choose from the matrix is 2, 4, and also negative 3 from the matrix row 1. For the coefficients, plus positive 2, negative 4, and also negative 3 is come from the, for example, for the 2 is sitting in the position A11, 1 plus 1, the row plus column, 1 plus 1 is equal to 2, so it's positive 2. For the 4 is sitting in the positions A12, 1 plus 1 is equal to 3, so it's an odd number, so it's negative. For the negative 3, it's sitting at the position 1, A1, 3, so 1 plus 3 is equal to 4, it's an even number, so it's positive. Next, I would like to explain about how to get the negative 5, 2, 3, 2. When I choose the number 2, and then we'll delete the row and also the column, so the rest is negative 5, 2, 3, and 2. Same with others. And then for in the determinants, negative 5 will times 2 minus 2 times 3. Same with others too. And then we will calculate until the end, we get the final answer, negative 76, not equal to 0. It's mean non-singular. It have a inverse matrix. Next, for the Roman 3, the questions need us to find the adjoint A. To get the adjoint A, we need to do 3 steps, which is minor, cofactor, and also transpose, in order to get the adjoint A. So from the matrix A, we calculate the minor, which is from M11 until M33. So next we calculate the minor 1 by 1, negative 5 times 2 minus 2 times 3. And then the rest also calculate in the same way. And then we will get the M is equal to a 3 by 3 matrix. Next we do the cofactor, which is add on the negative and also or the positive in front of the number. For example, for an even number, we'll add a positive, for odd number, we get a negative. For A11, row plus column equals to 2 is even number, so put it a positive. For A12, for example, A12, row 1 plus column 2 is equal to 3 is an odd number, so it's a negative. After we've done the cofactor step, we move on to the last step, which is transpose. So transpose means that we convert the row become the column. For example, for negative 16, negative 8, and 4 become the column. And for the second row and third row, we also be converted to the column. So the final answer is calculated. Next, for the Roman 4, we need to solve the vector of equivalent price. So here we're going through 2 steps. First, find the inverse matrix, and last we get the X. To get the inverse matrix A is 1 over determinants A times adjoint A. Negative 1 over 76 will multiply the whole matrix, and the final answer for the inverse matrix, we get a 3 by 3 matrix. Next, we calculate the X. X is equal to inverse matrix A times Y. So the 3 by 3 matrix times 3 by 1 matrix, we get the 3 by 1 matrix. The Y is 12, 13, and 17. So the Y will times the inverse matrix A and combine the answer. And the last we'll get P1 is 7, P2 is 4, P3 is 6. This is the final answer for the Roman 4. For the last questions, Roman 5, the question needs us to verify the P3 values by using the Cramer rules. So first we rewrite the matrix equation, and to get the P3, we need to get the determinants A P3 first. So we substitute the number 12, 13, and 17 into the third column of the determinants AP3. And then we calculate the answer for the determinants AP3, which is negative 456. Next, we move on to get the answer P3. P3 is equal to determinants AP3 divide determinants A. So we substitute the answer of the determinants AP3 and also the determinants A. And then the final answer will be 6, which is same with the previous answer, P3 equals to 6. Next, we move on to the next topic, derivative. The first question is fx equal to 1 over square root 2x plus 1. We rewrite it into 2x plus 1 power negative 1 over 2. And then we use the general power rules to do the first derivative. The negative 1 over 2, put it in front, and remain 2x plus 1. The power negative 1 over 2 minus 1 equal to negative 3 over 2. And then we differentiate 2x plus 1, we get 2. And then we rewrite the function to get the final answer. For the second questions, the function given fx equal to x squared times exponential power 3x. For these questions, we are using two rules to solve the questions. The first one is the product rules, the second one is the change rule for exponential function. For the change rule for exponential function, we apply at the second step of the first derivative, which is exponential 3x times 3. And the product rules we also apply on the second step of the first derivative. And then we solve it, and then we'll get the final answer, which is already factorized from the previous step. For the questions A21, questions 2D, the function given is fx equal to ln in bracket x squared plus 1. For these questions, you need to find the second derivative. So the first derivative, we use the change rules for logarithmic function, and then we get the answer 2x over x squared plus 1. 2x is the product of, we differentiate from x squared plus 1. Okay. For the second derivative, I use the quotient rule to solve it. First, we write x squared plus 1 and differentiate 2x to get 2 minus 2x, and differentiate x squared plus 1 to get 2x over x squared plus 1 squared. And then calculate and solve the functions. In the second last step, I factorize the numerator, and the last step, I just rearrange the negative x squared to behind. That's it, the final answer for D. Next, move on to the extra questions. Question number 1. The function given gs equal to s squared minus 2s times exponential power 4s. To get the first derivative, here I use the product rules and the change rules for exponential functions. First, rewrite s squared minus 2s times, we differentiate exponential power 4s to get exponential 4s times 4, plus rewrite exponential 4s, and then we differentiate another one, s squared minus 2s, we differentiate and we will get 2s minus 2. And then for the second step of the first derivative, I factorize out exponential power 4s from the equation. And then we calculate the functions inside the brackets to the end. And the last step, I factorize again to get the final answer for the questions number 1. For the last questions, the functions given hm equal to square root m cubed minus 5m plus 10. First, we rewrite the functions become m cubed minus 5m plus 10 power 1 over 2. To get the first derivative, here I use the general power rules. First, the power 1 over 2, put it in front, and we rewrite the functions m cubed minus 5m plus 10. And the power minus 1 become negative 1 over 2. And the last part, 3m squared minus 5 is the derivative from m cubed minus 5m plus 10. And the final answer is shown in the fraction form, which is 3m squared minus 5 become the numerator, and 2 times square root m cubed minus 5m plus 10 become the denominator. This is the final answer for the last questions. That's all for my video. Thank you for listening.